Hey guys, just trying to get lesson 11.1 here and give a couple examples that will help you. And I can guarantee that problems 4, 6, and 8 are probably your 3 hardest problems that you had to work with. And I'm going to show you a couple other ones that I think are just fun to do that are going to be helpful. But the key thing is redraw your diagrams, mark them up. So number 4 should be the hardest one. Now this is when you have a common tangent. And they gave us these 2 circles. And I'm going to draw them a little bit, I think a little more proportional in some sense to kind of give you an idea here. And we have our centers, we have M, we have N, and we have our points Q and P. And notice they don't use any top points, so I'm not going to actually apply those on here. But it says on the first one, it says find the distance between the centers of pulleys round to the nearest hundredth. So here we have our centers. We are round to our nearest hundredth. So I'm going to draw in the radii to the points of tangency. You see here is Q and P. They tell us this is 14, and here this would be 4 inches, and this one would be 5 inches. Now remember the key with these that I told you is to always draw in with your radius to the point of tangency your right angles. Then here's the key thing, and if you draw it this way, I promise you you'll get this right. You draw it so it's parallel to the common tangent, okay? So these are going to be parallel to each other. When you do that, you form a right angle, okay? And when we do this, I use it to solve, and I'm looking for the distance between, so this is X. I'm actually going to use this little right triangle right here. My whole goal is to use this triangle, and I'm going to actually highlight it here. The problem is I don't know the length of the legs, but I can get there pretty quickly because when I draw it parallel to the tangent, I draw a rectangle. So I know the opposite sides are going to be congruent because the rectangle is a parallelogram. I also know the radii is 4 inches here. So I know over here, because it's going to be the same side, this is 4 inches. That leaves 1 inch on top. And then we just plug it in. So then I have the right triangle, leg squared, hypotenuse squared. So 1 squared plus 14 squared equals x squared. So that's 1 plus 196 equals x squared. I get 197 equals x squared. And then you take the square root of both sides. And the cool thing is I can do this to the nearest hundredth, which is 2 spots after the decimal. X is approximately 14.04, I do believe inches is what they used on this first one. Then on 6 and 8, they're going to use exactly the same diagram, but they're going to ask you to use different numbers. And 6, you're doing the same thing. You're just going to use a different radii length. So I'm actually not going to do number 6. Just do the same exact process, but label differently. I'm going to do number 8 here, okay? Because I think that's kind of the critical one to get. Number 8, and I'm going to draw it big again, even though it's exactly, again, the same almost diagram. Okay, here we have our 2 centers. Okay, here's N, M. I'm going to draw my common tangent. Draw your radii in to the common tangent. You get your right angles. All right, here we have Q and P. Draw it to parallel to our common tangent. All right, let me label the different parts. On number 8, we have MQ, which is this whole thing is 5 inches. We know NP, I do believe, is 4 inches. And then we have MN, which is 14. Now, remember, we draw this so it's parallel to the common tangent, so we get these right angles. So here is that right triangle again. And I'm looking for QP, so I don't know this one. Well, opposite sides are congruent again. Oh, that's a leg of that right triangle. If this segment's 4 inches, oh yes, that segment's 4 inches. That leaves this one to be 1 inch. So literally I go 1 squared plus x squared equals 14 squared. Now they say give this to the nearest tenth. Now I really almost don't like doing that because when you do it to the nearest tenth, it's actually almost the same size as the hypotenuse itself, but it's an approximate, so it's not the most exact answer, so I'm having problems with this. I get x squared equals 195, and then x is the square root of 195. Well, if you go to the nearest here, 10th, that ends up being 14.0 inches. But we really know it's 13.9 something inches, but that is to the approximate value. But notice we set them up the same way. I just make sure I draw my line parallel to my common tangent, which gives me that rectangle, and I can solve for the missing right angle. So those were going to be the hardest ones. I was trying to think, I was looking through the homework examples that we were working on. I think I'm going to show you 16 because the same type of process is used for 16 and 18. And then 14 I'll just show you, but there's a longer explanation. So let's go ahead, I'll flip this over and do number 18. Okay, on 18, you're going to have a circle, and we're using the fact that if I have tangents coming from the same, and this is where I do not draw well, so you're going to have to help me a little bit here. I think we've got, okay, here, that is a very poorly drawn diagram of what I'm doing here, but I'm asking you to find the perimeter of this, and this side is 15 centimeters. I think this one is 7 centimeters. Over here, that's 7 centimeters, and this is 6 centimeters. What do I have? This one is 12 centimeters. Like I said, I didn't draw this to scale, and I need to know the length of this side of that polygon in order to find its perimeter. But I use the fact that I know that tangents from the same exterior point are going to be congruent to each other, and so I can use that to my advantage. All right, I got a phone call. I will finish this in just a second.